Hello students, in this session we'll talk about the application in case when one-way analysis of variance or H naught of one-way analysis of variance is rejected. So we need to apply another procedure that we call Tukey multiple comparisons that is related to one-way ANOVA. Tukey multiple comparisons is the technique that we apply in case of the rejection of null hypothesis in one-way ANOVA so that we can identify the pairs of means responsible for the rejection of H naught. And the formula in general form is this one: x bar I minus x bar j plus and minus q alpha divided by root 2 times standard deviation multiplied by square root of 1 upon ni plus 1 upon nj. Over here we can continue with the same data or question in which we have applied or used to see the effect of advertising policies. Over there, first column has a sum of 135. If you want to compute mean, then 135 divided by 6 would give us the mean value. And that is 22.16, I believe. 135 divided by 6 gives you 22.5. Then x2 bar we can compute in the same way, and 139 is the sum of the second column divided by 6 is 23.166667, so we can write it down as 23.17 rounded after two decimal places. Similarly, x3 bar, the sum of the third column is 169, again divided by 6. So 169 divided by 6 gives us 28.17. If we would like to go for the comparison of mu1 minus mu2, for instance, so the description of the for the subscripts I and j will be x1 bar minus x2 bar plus and minus q alpha divided by root 2 times standard deviation times square root of 1 upon n1 plus 1 upon n2. So this is how we can apply the values in places of subscripts. Now, how do we compute standard deviation? Is simply the square root of mean sum of square of error, what we have computed in one-way ANOVA already, and the value over there was 6.74. So square root of 6.74 we can compute. And also, if we look at the number of observations in each column, since all the observations are equal in every column, therefore this factor that is inside the square root part, 1 upon n1 plus 1 upon n2, or 1 upon n1 plus 1 upon n3 in case of comparison of mu1 with mu3, and 1 upon n2 plus 1 upon n3 in case of comparison of mu2 minus mu3. So in that case, this factor will become constant. S, which is standard deviation of square root of standard deviation, and which is equal to the square root of MSE, that would remain same as well. Q alpha is the value that we get from Q alpha table, and Q 0.05, in fact, the level of significance at which we have performed this hypothesis. In a prior situation, in case of ANOVA, we have used 0.05, so Q alpha would be equal to 0.05, and this gives us the value of 3.67, and this we can compute from the third column from that table and the 15th row from that table, and this value is in fact 3.67. So now better if we compute this margin of error part of this CI formula, because this is looking like CI formula. So Q alpha divided by root 2 times square root of MSE times 1 upon N1 plus 1 upon N2. That's Q alpha is 3.67 divided by square root 2 inside the square root 3.67, then inside the square root 1 upon 6 plus 1 upon 6. So when we compute this entire answer, this would become 3.89, I believe. Let's try what answer we must be getting. That's inside the square root 1 divided by 6 plus 1 divided by 6. That's 0.577. So this factor is coming up 0.577. Multiply this answer by square root of MSC, which is 3.67. Sorry, it's square root of MSE is 6.74. Make a correction over here, please. So 6.74 and then multiply by 3.67 and then divide this answer by square root of 2. So 3.889, that is nearly equal to 3.89. So this entire answer is 3.89. Now what we do, for mu1 minus mu2 difference, we need to simply substitute 22.5 in place of x1 bar, take away 23.17 in place of x2 bar, and plus n minus 3.89. We get the lower bound and then the upper bound after applying this. So 22.5 minus 23.17 is minus 0.67. That's minus 0.67 plus minus 3.89 would give us the lower bound of minus 4.56, and the upper bound value is 3.22. So recall the approach that we have used already in case of comparison of means, when we would like to make comment on the difference between the two population means, that is based upon the sign in on the lower bound and sign on the upper bound. The signs are conflicting. Lower bound is giving us negative sign, whereas upper bound is giving us a positive sign. Therefore, we would be indifferent, and we can consider both mu1 and mu2 nearly equal. Now, going for the comparison of mu1 versus mu3, we have to go for, in this case, the difference between x1 bar and x3 bar plus and minus the same thing. Formula remains same. N1 and N3 now. And this entire part would be same as 3.89, what we have worked out before already. This is 22.5 minus 28.17 would give us the answer is minus 5.67 and plus minus 3.89. This again would give us the two bounds for the comparison of for the difference between two population means as minus 5.67 and minus 3.89. The lower one is coming up minus 9.56, whereas the upper bound is coming as minus 1.78. Over here, you can take notice of one thing that both the bounds are ending up with negative sign, and whenever this is the case, we can draw this conclusion that the difference between mu1 and mu3 is coming up or appearing negative does imply that mu1 is less than mu3 is the conclusion that we can draw. Now when we go for the comparison of mu1 and mu2 and mu3, so the formula should be x2 bar take away x3 bar and plus minus the same factor q alpha divided by root 2 times standard deviation times 1 upon n1 n2 plus 1 upon n3 now. But no worries, this has the same value plus n minus 3.89 and 23.17 take away 28.17, that are the values of x2 bar and x3 bar respectively, would give us minus 5 as the difference between the two. Now the values would be minus 8.89 for the lower bound and minus 5 and plus 3.89 would again give us a negative answer, which is minus 1.11. So again, we are ending up with the same nature of relationship between the two means, and this due to this we can come up with a deduction that mu2 is also less than mu3. Over here, if you look at the common factor between these two findings, this one and this one, we can conclude that mu1 is nearly equal to mu2, but mu3 is clearly giving us the greater amount of sales or greater revenues in terms of sales as compared to all other advertising policies. The other two advertising policies, that is policy 1 and policy 2, are giving us on the average similar amount of sales or number of sales or volume of sales. Not volume, in fact, these are the sales value. And similarly, uh, we can draw this conclusion that that policy 3 gives us the highest amount of mean sales. So this is how we can perform Tukey multiple comparison. And that's all for this